are going to discuss further into these tables, and followed with we are going to discuss about partitioning, how to create a partitioning. So here how you can make use of some sample tables to create partitioning and bucketing. Then after that we will be discussing about joins. What are all the various types of joins? Then in terms of Hive, in advanced joins, we have some SMB join, map only join apart from normal map, where to make use of those joins. These are all the things that is planned for today's discussion. Okay, let me start our discussion on Hive tables now. Okay, so let me start now.
And discuss about Hive manager tables. Under Hive manager tables, we have discussed about both the unpartitioned, non-partitioned tables and partitioned Hive tables. Now we are going to discuss about this external table. Under external 2, you have this non-partitioned or unpartitioned external table or partitioned external table. So the partitioned external table can be further refined by going through a concept called as dynamic partition. So this is the flow that we are going to proceed now. Now we are going to start our discussion on Hive external table. So we have already discussed about the differences that the manager table and external table differs by. The prominent difference is, if it is a manager table, each and everything will be managed by Hive. If you are going to work with your data only using Hive, you want to create an external table. If it is a external table, if it is a manager table, then if you drop the table, both the tables, the metadata as well as the original data will be dropped. Whereas if it is an external table, so Hive doesn't have a full control. The user will have a control, under which the metadata information alone will be managed by the Hive. Data won't be taken care by the management. If your application, if you are going to write a business logic, not only it is going to be used using Hive, also your business logic you are planning to implement using apart from Hive like P. Under the circumstances, it is recommended to go for creating a Hive table as an external table. Also, because if it is managed table, you can make use of only Hive only. You can't make use of data accessible from the managed table using P. If that's the case, you need to go for creating an external table. If you drop the table, being the metadata information alone being associated with Hive, excluding the data, it drops only the metadata. Okay, this is the way by which we need to go for deciding whether it is managed or whether it is an external table. Okay, so now we are going to discuss about how to create an external table. So also I have let you know, if you create a managed table, the location where to store tables data is a fixed one. It is under user Hive warehouse. Under the location only your data will be stored. Whereas in the external table, the user want to specify the location where to look for the data. Okay, it won't have any default location. You need to specify at the time of creating the external tables. Okay, so you need to specify where the particular table need to look for data. Okay, then we create an external table and we specify all those information here. So before that, what you need is, you need to have a data file. Is it okay? Let me start with creating the external table for the same purpose. Create only one thing. You want to add a keyword external. That's all. Create external table. The table name, ID, integer, comma. Let me make remaining thing are same. Name. Okay. So I have cut shorting city. So what you need to specify, row format. You want to fill this value with the data type. Okay, row format. You want to specify it is a delimiter, and then fields terminated by. So in our data set, let me take a small example with fields, one field and another field terminated by comma as a separator. And this is the key word that you need to specify. You need to specify the location of the data. Location. Here the location need to be specified under the, okay, it may be you have a location by name user. Under user, let me have a folder by name RAM, and let me have a sample tab. Okay. So this is the location where you need to have in your HDFs. Let me please make a note. This location where you need to have in your HDFs. So if this location contains this sample.txt file, what happened here is at the time of creating the table itself, the data will be mapped here. You no need to explicitly specify a load statement to load the data. While creating the data itself, you can able to store the data here. If you simply select start from customer, what happens here in this case? If this sample.txt contain data, automatically a customer table will be created with the ID and name and city, and whatever the data that you have specified here will be mapped and stored here. If you simply issue customer, you no need to use load statement. Load data statement is not at all needed here. So because you have already specified the location, if the location contains data, the data will be fetched. If you does not have a file here, the sample.txt file, no issue. If you simply select start from customer, it will return a zero output. That's all. That means it doesn't return anything. Later stages, you can add the sample.txt at the specific location. Once the sample.txt has been added, after that, if you issue a query, the query will fetch the data. Please make a note. These are all some of the key things associated with this external table. So you have created a table, an external table with customer with the ID, name, and city, and you create the table as a partitioned table. So here you have specified the format, and later stage once you create a table, you can add the value to the table. The data can be added to the table by using the alter table statement. Okay, you no need to use this load here. You can use the alter table, the name of the table. You are specifying the partition field, country India, and you have specified the location here. Then all the associated information in Tamil Nadu.txt contain only ID, RAM, and city. Not this information. Please, very, you want to be careful. Information associated with country in India, state equal to Tamil Nadu, is not present in Tamil Nadu.txt. Tamil Nadu.txt contain information only in the following manner. It won't have a field, it won't have a value for the country and test. At the time of loading the data, then automatically this one RAM Madurai will be read from this file Tamil Nadu.txt. At that time, here in country India and state Tamil Nadu will be appended. Please make a note very carefully. If you want to get this information of partition, the command is show partitions. How many partitions a table contains? Show partitions, the name of the table. The table name customer will let you know how many partitions are there. If you want to drop the partitions, okay, similar to that of add, what you can do? You can also specify alter table name. Instead of add, you drop partition name. That's all. Okay, you no need to specify the location. Please make a note. If you want to drop the partition, you can drop a partition. In this case, all the data associated with that partition will be dropped. You drop a partition, all the data associated with that partition will be dropped. You can go on create the partition. You can go on drop the partition according to your requirement. So here in this example, we have using this alter statement, we have added the partition value countries equal to India, states equal to Tamil Nadu. Imagine we have data country states equal to Tamil Nadu, states equal to Karnataka, states equal to Andhra, states equal to Maharashtra, states equal to Uttar Pradesh, states equal to Madhya Pradesh. Each and every time I may need to add this alter table, add partition, alter table, add partition. No, you no need to write multiple alter table statements for each and every time. So am I making sense? Okay, here you have alter table customer, add partition, country is equal to India. Similarly, alter table customer, add partition, country is equal to India, state is equal to Karnataka, and location user RAM, Karnataka.text. Similarly, user RAM, Andhra.text. Each and every time, if you want to add the data for all the aforesaid partitions, whether we need to use alter statement each and every time, the answer is no. What you can do, you can go for the concept called as multi-table adding data by reading data one time and adding multiple time. Okay, so multiple, no need to write a multiple alter statement. You can write a single alter statement and you can directly specify the partitions. Okay, how you can make it? Please make a note. In this case, you can write a simple alter statement. You can specify the partition. Alter table, customer, add partition. Okay. So how to add this? Alter table, table name, add partition. The first partition, country is equal to India, and you want to specify state is equal to Tamil Nadu. Insert state is equal to Tamil Nadu. And if you have data, you want to specify the location. Under home, let me assume that you have data Tamil Nadu.text. Okay. Similarly, what you can do, you can specify the other partition without using a separate alter statement. Simply partition, country is equal to once again India, state is equal to Karnataka. Let me make it Karnataka, and the location, you should specify the data associated with this Karnataka.text. Likewise, what you can do, you can go and add the needed partition if you have the data. The partition state is equal to Andhra. Okay, you can go on and add. At the end, it should be terminated with the semicolon. That's all. Okay, at the end, it should be terminated with the semicolon. This is the way by which, using a single alter statement, you can go on add the partition as you like. Okay, so this is what with respect to how to create an external table. Okay, and how to add the data. So just a recall what we did. So we have initially started our discussion on managed table. We have started our discussion on this managed table. So under this managed table, what we did, first we have created the table, and after that we have loaded the data using the load data statement. Using load data, we have loaded the data into the table. Okay, so if it is an external table, we are talking about an unpartitioned table. Initially, we discussed about this unpartitioned table. If it is an external table, then what we did, we create the table. At the time of created the table, we specified a key value called as location, which specifies the location of data. You no need to have a separate load data statement explicitly. Okay, this is the way by which we make use of creating a managed table and loading the data, and creating the external table and load the data by specifying a keyword called as location. If it is a partitioned table, okay, if the external table is a partitioned table, what happens? So here in this case, we use a statement called as now alter table to add new partitions. At the time of adding the partition, what we did, we specified the location. Okay, so here the thing I want to make you understand here is the load data statement is used to loading the data into the manager table. Okay, so if it is a external table, you don't need to use this load data. So here, if it is a manager partition table, you can specify the partition value by simply typing the partition. By loading the data, you need to specify the partition class. Again, if it is a external table, you no need to specify a load statement. You can go on add the partition using this alter table add partitions. Okay, these are all the things associated with a partitioned table and unpartitioned table for both managed and external table. Now we are going to start the discussion on further how to, with the use of some real-time example. I am going to show you a real data sets using which we are going to discuss. I am going to do practical what we have did so far. So before going into the practical, if you have any doubt, please let me know. Okay. So let me create a table by name employee. The employee table contains all the information. Let me make it the employee number, the employee name, etc. Okay, it is a unpartitioned table, a normal table. From employee, we are going to create a table called as a partitioned table. Okay, the partitioned table. How to load the data into this? That is what that we are going to do. That we create a table by name employee Hive. It is a partitioned table. Now we are going to discuss how to load the data from unpartitioned table into the partitioned table. That is what we are going to discuss. This is your introduction. After that, we go for the concept of dynamic partition. Okay, let me create a table employee number, employee name. We have a salary field. We have a country. We have a state field. Being it is an unpartitioned, you have all those things. Okay, so let me create for this purpose. We make use of this external table. So what you need to do? You want to create a table. Create. Being it is an external table, external unpartitioned table, external table, name of the table is employee. Let me have an employee number, integer, comma, employee name, varchar, salary is a float, and we have a country, varchar, and you have a state, varchar. Okay, so being it is a external unpartitioned table, we are giving values for all those things. Continue. And after that, you want to specify the row format delimiter. You want to specify the source fields terminator. These are all the mandatory things. So because since you are having your data set, which is not going to be follow the default format of Hive, you want to specify this thing. Being it is an external table, you can specify the location. The location was found to be HDFS under user RAM. That we make it to sample.text. This is the data. Okay. Now after that, the data will be loaded. If you simply issue, select the start from employee. If your sample.text contain data, automatically the data will be loaded here as a XML table, and you can able to query the data. Now what I am going to do? Assume that this data contains records for country India, and states equal to Tamil Nadu, states equal to Andhra, and states equal to Karnataka. It is now this table contains the information belonging to all these things. Okay, you have employee number, employee name, salary, country, state. All the information should be loaded. Here you are going to create a table which is a partition table. The same thing: employee number, employee name, and salary. You are going to create a partition based upon this country and state. And after that, if you load the data into this from the unpartitioned table, and you have a separate partition. Okay, one for country is equal to India, and you have a state is equal to Tamil Nadu. You have a separate area for partition. Similarly, you have employee number, employee name, and salary organized into country is equal to India and state is equal to Andhra. Country is equal to India and state is equal to Andhra. Similarly, country is equal to third partition. Country is equal to India and state is equal to Tamil Nadu. Tamil Nadu, Andhra, Karnataka. So this is what that we are going to practice now. So for that, what you need to do, you want to create a table. The command is the same thing. Create table. Instead of creating an external table, let me create here the normal partition table and load the data. Okay, from this external unpartitioned table into a normal partition table. I manage the partition table. The command to create is create table. Let me make the name of the table is employee Hive. The same thing. Employee number, comma, employee name and salary. Okay, what you need to do? So you want to specify the function keyword partitioned by. You want to specify what are the partition. Country. Again, it is a string or webcast. You can make it anything. State. It is a string or webcast. Okay. Once again, row format delimited, fields terminated by row format delimited and fields terminated by comma. Okay. So you have created a table. Then how to load the data? To load the data from this external unpartitioned table into the partitioned table, we can go for a concept called as insert override. Okay. So now we are going to load the data. How to load the data? The command is insert override table target table. The name of the table is employee live. You want to specify the partition. Partition country is equal to India, comma, state is equal to Tamil Nadu. Here you want to select employee number, employee name, comma, what field that we have. I think so, job. Okay, job from the source table, employee, where country equals India and state equals Tamil Nadu. What happens here is we have inside the employee field contain employee number, employee name, job, country and state. And we have the employee table, employee Hive on the other side. This is a partitioned table. We have data partition based upon states equal to Tamil Nadu, states equal to Andhra, and states equal to Karnataka. So you have all the data, unpartitioned external table or anything. Here what happened, the first query will read and it will check whether India and Tamil Nadu. If that is the case, the data will be put in India and Tamil Nadu. Similarly, if you want data for Andhra, states equal to Andhra means it will load from this source only the condition satisfying states equal to Andhra into the Andhra. So this is the way by using insert override table name, you can be able to select data from this source table and to insert the data into a partitioned table. The source table here is unpartitioned table. The target table here is it is a partitioned table. Please make it. Now after loading the data, if your query contains select start from employee Hive, where state equal to Tamil Nadu instance. Yes, the query will facilitate you the fast retrieval of data, being your data is organized based on a specific Tamil Nadu, Andhra, and Karnataka. So this is the way by which you can go for inserting the data by reading the data from one table to the another table. Okay, please make a note of this thing. Note it. This is the fixed agenda until the next instruction. For all our subsequent classes, we have a Friday. It starts at night 10.
So here, what so what we have discussed so far is how to create a partition table. So let me do the here. Next thing that we are going to discuss is dynamic partition. Before going into this, let me do the practicals. Okay, what are all the things that we did? Let me do the practicals of how to create a complex data type and how to insert data and how to do this partitioning. Okay, so and all of that stuff before proceeding into further. Okay, so I need a break for 10 minutes from morning 6 onwards. I am in class. Kindly give me a break. I will go for Tiffin and be back now. Time is 9:45. I will be back at 9:55. So we can continue from there. Okay. So take a break and be there. Was extremely I couldn't able to continue. Be back at 9:55. Okay, can we continue? Ashok sir, Selvi ma'am. Yeah, what we have discussed here is how to transfer data from a non-partitioned table into the partitioned table. Here we have discussed with the example of two things. One, we have an employee table. From employee table, we are partitioned table employee Hive. Okay, so this partitioning is based upon country and state. So here what we did, so we did a multi-table insert here. From employees table, we are inserting into employee Hive table based upon the particular partitioning. Here, we want to specify the partitioning condition. The country is equal to CA, state is equal to Ontario. So what happened here in this case? Those records which satisfies the condition, okay, with country equal to history and state equal to Ontario, has been selected from employee statement and it will be placed here in the employee Hive table. Okay, imagine since in our example we have only 6 partitions. 3 partitions for US, one for Canada, another one for German life. It is very easy writing this coding from reading the table employees one and insert into the employee side, specifying the partitioning. If it is 6 partitioning, then it will be easy. Imagine if you have 100 partitions, if you have 200 partitions. For each and every partition, you need to write coding not less than 5 lines. If it is 100 partitions, this particular script itself need to contain 500 lines of coding. To avoid this, we go for concept called as dynamic partitioning. So we are going to discuss the concept of dynamic partitioning now with this following example. Okay. So here for dynamic partitioning, we want to set certain parameters that we are going to discuss about. But you need to insert. Okay, dynamic partitioning is one of the most important concepts. Check this dynamic partition instead of writing a lengthy statement to insert data from a normal table into this employee partition table. Yes, the dynamic partition will make it in a simplified manner. Okay, in Hive, the dynamic partition, in order to invoke this dynamic partitioning, we want to set certain parameters. Okay, you want to set following parameters. By default, it won't be invoked. Okay, what are all the things that you need to set? First thing, you want to set, please make note of this command. Set Hive dot execute dot dynamic not partition. This is the first parameter that you need to set. Okay, you can set using a set statement, or you can directly set this using hive-config file. Okay, the set is used to activate immediately for this particular session. Set hive dot execute dot dynamic dot partition. Okay, here you want to set the second thing. Okay, this value needs to be set as true. This value needs to be set as true. Then the second property that you need to set is mode, dynamic partitioning mode. Set hive dot execute dot dynamic dot partition dot mode. Then there are two options. One is strict and another one is non-strict. Then the mode is need to be set Hive dynamic partition mode need to be set as non-strict. Please note what are the parameters that you need to set. So maximum number of partitions you want to set. Set Hive dot execute dot max dot dynamic dot partition. Max dot dynamic dot partitions per node. Partitions dot per node. Check you want to set the value. Check that
maximum number of partitions that each mapper and reducer can create. The default value will be 100. You can make use of the same value. If you want to increase, you can increase. Default value is 100. Okay, that's maximum dynamic partitions per node. Maximum dynamic partitions. Okay, so overall partition for all the nodes. That's Hive dot execute dot max dot dynamic dot partition. This corresponds to the number of partitions per node. This corresponds to number of partitions per cluster. The value will be by default 1000. We can make use of the same thing. Okay, and you want to set the final parameter, the maximum number of files that you can create. Set Hive dot execute dot max dot creator dot file. Here, the maximum number of files that you can create is 1 lakh. Okay. So if you want to set, you can set the value, new value. Set if you want to make it as 2 lakh, then you want to set the value equal to 2. These are all the default values. Okay. The number of the dynamic partition mode need to be non-strict. If it is strict, it may result in some error. Then you want to set it as a non-strict. You will have maximum number of dynamic partitions per node, and the maximum number of partitions allowed in the entire cluster, and finally number of files that you can create. Okay, so these are all the options that is needed. You can set if, for example, by default it will be set as strict. You want to make it as a non-strict, simply equal to non-strict. That's all. Okay. So set Hive dot dynamic partition dot code equal to non-strict. This default is the strict. So these are all the parameters that we need to set. Okay. After setting these parameters, what we need to do, using a simple statement, we can able to get this is a employees table. The employees table contains 107 records, I think so. Here, this is your employee Hive table. This employee Hive table is a partitioned table. You need to organize your data in this partitioned order. There are 6 combinations. Okay, US, and only is Canada, and remaining I think so Europe and Africa. Okay, there are 6 combinations. All the records need to be from this source need to be transferred into the target. This is our target. Okay. So then how we can simplify this activity using dynamic partition. This is the query. I insert override table name. Insert override table name, target table name, employee Hive. Yes, the partition is country, state. You need to specify only the partition field. So no need to specify the value. Here you can select ID, first name, last name, email, hire date, salary, department, city. We have already discussed the parameters. That is present in the employee table and employee city, street, and zip. Finally, country and state. From where? From the employee table. So first, all the contents from the employee table will be selected. Okay, this statement will select all the 107 records, and it is going to insert into the employee Hive. So based upon the partition. So you have a country equal to US and state the following 6 combinations to be installed. Okay. So this override, what it will do, if you have some data already present in employer, all those data will be removed. Okay. This select statement will read the records from the source table, and this statement insert override statement will insert the record into the partition table employee Hive based upon the country and state unique value. Okay. This is a way by which by making use of this dynamic partitioning that you can able to insert data in a simplified manner. So this is an example of dynamic partition. The difference between this partitioning and before discussed is before discussed you want to write a lengthy query. So for each and every partition you want to write a coding of 5 queries. If there is a 6 partitions, you want to write 30 line coding. Instead of that, just within 4 lines, irrespective of any number of partitions, we can able to load the data. That is the advantage. Automatically, all the partitions will be loaded. Okay, so this is the way by which you can make use of this dynamic partition. One of the most important concepts. Next thing, Hive bucket. So a bucket is almost similar to of your dynamic of your partitioning, but the thing is that you can control the number of buckets in which your data needs to be organized. Imagine you have 100 records. You are going to partition based upon one particular, let's make it country. So in these 100 records that you assume, you have 100 unique values for country field. So if you go for partitioning, then if you partition based upon country, then you need to have 10 partitions. Here if you go for bucketing, you can specify the number of buckets. In this case, let's make it the number of buckets to be 3. Bucket 1, bucket 2, bucket 3. Bucket 1 starts with B0, B1 and B2. The formula here is based upon the country value, the value of the country will be taken for a particular record, and the value of the country is applied to one hash function. The hash function will produce one output. The output of the hash function modulus the number of buckets. Okay, the number of buckets that we are going to create will produce one unique value. Okay, so the value will be, for example, let we make any value. We have a unique value, India, here, UK, Australia. Okay, so the country value, take India as the first value. If you imagine the hash produces a unique value of 10, then 10 modulus number of bucket 3, remainder 1. Then India will be placed in the bucket 1. The second, US, let we imagine US produces a value 9, modulus 3 will result in a remainder 0. US will be placed in the bucket 0. And UK, let we imagine UK produces a value 13, 13 modulus 3, remainder 1, UK will be placed in the bucket 1. So Australia, let's imagine produces a value 8, 8 modulus 3, 3 2s are 6, remainder 2, Australia will be placed under this bucket. So any value on this country field will be organized under this 3 buckets based upon the particular formula. This is called as bucketing. Okay? So how to create a bucket? A simple thing here too, you want to set the bucket. By default, the bucketing won't be set. Just the command to set the bucket is set hive dot enforce dot bucketing is equal to true. You want to set this. Then hive dot enforce dot bucketing is equal to true. Once you set the bucket, you can create a bucket. Okay? So how to create a bucketed table? So this is the command for creating a bucketed table. Let me create a table. Create table. Table name. Here we make it the same name. Employee Hive. You have first name, which is of a string, comma. You have a job, again which is of a string, comma. You have a salary, which is the integer string, comma. You have a country. String field. Yes, you want to specify the bucketing by clustered by class. Clustered by the field that you are interested. Country is the field that we are interested. into number of buckets. Here the number of buckets in our example is 3 buckets. So you want to specify the row format delimiter and fields terminated by in your source comma and the separate. So this is the way from which you need to create a table. Okay. So how to load the data into the table? The same thing. So the same source table that we make use of from employees insert override table employee Hive. Insert override table employee Hive. Here you want to select all the things. Select the first name, comma, job, comma, salary, comma, country. Okay, this is the command that you need to do. Okay, so from employees, insert override table target table that you want to select. So what happened here in this case is the select statement will select from the employees table and it overrides into the employee Hive table. So here in the employee Hive table, we have already instructed that this table is clustered by the country field. Therefore, all the records that we instructed to organize all the data under the 3 buckets and all the records will be organized under these 3 buckets. Okay, so here, that's these 3 buckets, how you can able to access these 3 buckets. The name of the bucket will be in the following manner: 0000 underscore 0. 60 underscore 0 is the 0th bucket. Then 00001 underscore 0 is the second bucket. 00000 1 to 50 2 underscore 0 is the 10th bucket. This is the name of the bucket that will be created. Where it will be created, those information will be created in the default warehouse directory. You can check using the following command: hadoop fs -ls /user /hive /warehouse. This is the default location where Hive manages the data, under which you have your database name. Let me make your database name city through database name, the name of the table, the target table. Employee Hive is the table. Under the table, you can able to find out all the files. 000 first file and second file and third file. Okay, this is the way by which if you have a splitter into 4 files, then the next file will be 00003 underscore 0 is the name of it. All the files will be organized under the following location. If you want to view the content, then instead of ls, you can directly specify a cat command. Okay, so else you can simply specify the select statement. So here in that case, if you want to find out the content of bucket domain, simply type the following statement: select count of stock from the table name employee Hive. Here you want to specify the table sample. Here you want to specify the bucket name, bucket 2 out of 3 buckets on the field, country field. You want to specify this. Then all the number of data present in bucket 2 will be listed. In our example, it will be 635. All the data as of our sample record. So that is the record as been stored in our bucket 2. Similarly, if you want to find out the value of bucket 1, instead of 2, you simply type bucket 1. Similarly, bucket 3. So this is the way by which you need to create a bucket, and you can able to find out how many records are there in the bucket. If you want to view the content of the bucket, so instead of ls, simply hadoop fs -cat. If you the name of the file 00000 underscore 0 will show you the content of the first bucket. So this is the way by which you can check how many files have been stored, how many records have been stored in the bucket, and to view the content of the bucket. Please make a note of it. Okay, you take this example, start the recording here. Yeah, please.
Raman, this is Srini.
Yes.
So Hive handles only the structured data.
No, it can handle all type of data. We are going to discuss how it can handle JSON format data. And while discussing, after discussion of this map reduce, we are going to discuss the concept of UDF, user defined function. Here we will discuss how we can make use of file for handling other types of data.
Yeah, so far we discussed only the structured data, so I'm just checking it.
No, we cannot. So here what we are going to do is, so we have framed this document will be sent to you. So based upon the document content, so each and everything will be executed and shown to you. You also try to do in your laptop itself. After you just carefully observe what is going on. After that, you can try with your own laptop. I will send you the needed document. Okay, so kindly follow. That is where basic you know how to configure Hive. These are all the Hive configuration steps that we take. We are trying to start first by creating a basic database. From the database system, we are going to start. Abhi is going to manage this. I hand over the system to Abhi and also get. Good evening, everyone. First, we have to move into Hive shell. For this, I am giving the command Hive. Taking some time. Okay, we are inside our Hive shell. Let me exit. Exit Hive and enter into Hive once again, so that I can show you how I started actually. So
Abhi, execute one by one. Okay. So being we have a 16 GB of RAM, it took this much of time. Okay. If you don't have enough resource, you can take it from cloud. We have already discussed how to make it in cloud. In cloud, you can, for doing these practicals, you configure your Hadoop in cloud and you can do the practical even with 16 GB.
If you want to keep track of which directory we are working in, if we want to keep track of which directory we are working in, we have to set this parameter using set command set hive.cli.print.current.pb. equal to true. So set this parameter to true, and along with the Hive shell, the current working directory will also be displayed. Sorry, it's a bit noisy over here. Sorry, it's a bit noisy over here. Okay. I'll set this command to true so that we can keep track of which database we are working in currently. Okay, this shows we are in the default database. Now, let me start from creating a database, dropping it, and let's go one by one then. Okay. So let's create database, database name. Database name, I'm naming it as user DB as given in the document.
This is the document that I am going to share.
Anyway.
Okay, so
to get into that database, we created user DB now. Before that, let me see that the database is created or not. It says OW, DATAB, show databases. This is the command to see whether how many databases are there actually. This is the user DB which we created just now. We'll use this database and enter this using use command. You can enter this database and work inside this database actually. Use DB. And see, we are currently working in user DB database just now created by us. If you want to drop this database, you can go on this command. We want to drop this database along with the schema. Along with schema, we can go on with this command. We just include the cascade command along with it. I'll show you how we do it. Let me see the databases. The user DB which we created just now has disappeared. I have dropped the database. If you want to drop the schema separately, if you drop the schema automatically, the database also goes away because just now we created a database also goes away from this list. Both the commands execute in the same way actually. You can drop schema also separately. Here we go. See, you already dropped the database, that's why it shows the database does not exist. So let me create the database once again. I'll drop the schema now. Let's see, schema alone is dropped now. Fine. Let's move on to the next commands. Let's create a table and then do the exercises. Let's create a database separately and do the exercises inside the database. Okay. TREATEEX Hive exercise exe Hive. Sorry. Okay, sorry. Create database exe Hive. This is the database we'll be working on. All the Hive exercises will be dealt with inside this database. Let's use it. You are entering the database exe Hive. Fine. Here we are inside this database. If
you see for the tables inside the database, you want to see for the tables inside this database, just give show tables. There are no tables inside. Now let's start with creating a table. Here we'll be creating a table with the name employee. This is actually if not exists, checks whether the table already exists or not. It's better to have this thing practice this thing, because if the table already exists, the command will throw an error. If this particular line is not used, if not exist line is not used, fine. I just copy paste the thing, because employee salary string. If you want to give comments, you can give comments using this comments line.
Yes, all the theoretical concepts have been already taken. That's the practical side alone is demonstrated for you. Okay, theory, all our clarification, doubts, clarification, everything has been clear to you. And this is the practical demonstration.
Row format delimited. Creating a table employee. Commenting employee details. Okay. Row format delimited, fields dominated by tab as a separator, and lines will be dominated by new line as a separator. Text. Okay. Here where we are going wrong. I executed. Nice employee string. Okay, again employee string. we need not include this command first. I think something wrong with that command. Something wrong with that command statement. We'll exclude the statement and then execute the remaining command. So format delimited. Is terminated by tab. Lines by new line as separator. Okay. And stored as text file. This table will be created as a managed table in Hive warehouse directory, which is already known, which is already been taught to you. Where I went wrong. Okay. Hello?
Yeah, it's showing 423, right?
Pardon?
That's the line 423 mismatched input. Expecting a string literal by the row. Cutting some syntax here.
Okay, sir. The string alone I've given in caps letter, that's the reason I think. String that, sorry. 1, 2, 3, 4.
Fourth line.
Just one, sir. Read table. Okay. Okay. Okay, sir. We'll type it separately, sir. No problem. Yeah. Int command name Pink. Pink. Destination is pink. Three. Pink.
What is designation?
It's a pretty significant, sir. I made a spelling mistake actually over here.
Yeah.
So it is very slow. That's the reason why it is stucking. Okay, I didn't have a configured Hive in my machine. It took additional 1.5 hours to configure. That's the reason we are playing with the Orbit system. Sure, I will share you the entire content. Okay, so for example, I am letting you know what is happening. Now let me look into this.
Copy pasted directly from the document file which I have created. The document file will also be shared to you.
The thing that we have discussed, how to create a partition and how to load data, is going to be demonstrated. So I will do you the practical demonstration for 2 to 3 commands, and remaining I will share you the document. You can continue with that. I will show 1 or 2 things. I want to
Here
start.
we are creating an employee table with all these name, string, salary, subordinates. Subordinates is actually a complex array data type. Deductions will be having map data type with key as string and value as float. Address is a structure data type which has street, city, and zip. Street will be will be having a string data type. City is also string data type, and zip is an integer data type.
Abhi, I had already explained those things.
Row format delimited.
So here we are overriding the default values. Collection items, map keys, instead of default control B and control C. Instead of copying and pasting line by line, you can create a script and you can invoke using the script that we will discuss in coming sessions. What are all the various ways by which you can create a Hive script, how to invoke and run those scripts.
This is the table you are creating over here. This is actually a managed table. Since being a managed table, all the managing properties of this table will be taken care of the Hadoop file system. Taking care of Hive actually. Sorry, taking care of Hive. This table will be having a name, salary, subordinates, deductions, address. All these columns. These columns. I'll show you the data set after creating this table. Yes. The actual data set bank for data.text. This is the actual data set we will be loading into that table. This actual data set. It has 10 records. This table will be loading it. As its name is string. Name is string. Okay. Salary is input. You can see here. Again, subordinate. Subordinate is an array of string. This array has two collection items. Two collection items separated by this colon. You can see it over here. We have mentioned it over here. The collection items terminated by colon. Fields terminated by comma. That's also here. Fields terminated by comma. Every field is terminated by comma. Key value pair in every map reduction. So deduction is actually hello. Hello, sir.
Hey, one question. How do you identify that this is a managed table?
Pardon?
How do you identify that this is a managed table?
Oh, I identify that this is a managed table. I'm not using the keyword external. If I give keyword external, then it will be taken as an external table. If I don't use keyword, by default it will be created as a managed table.
So when you drop all the corresponding things will be dropped in the managed.
It will be dropped along with the metadata of the table and as well as the table contents. Both the contents and table will be dropped if I drop this table.
Managed. Okay. The schema will remain the same, I think.
No, the schema will also be dropped, sir, because I'm dropping the entire table, sir.
Okay.
I will share you this data set also, else you can create your own data.
Now let's see how we load this tables. Load this bank data into this bank data.text into this table actually. Pardon? Hello?
Yes, Abhi, continue.
Hello, sir? The table is, the command is already here. I have already practiced it. You can just copy paste this for making it easier. I already practiced this and checked it whether it's working or not. Text file. And, into table employees.
So I will share you the document, you try with this, no issue. If you have stored your data in HDFS, no need to specify this local keyword.
LDCT star FROMEMPLO by displays all the 10 rows displayed. Here, if you want to access these fields separately of a complex data type, for example, for this data type, name data type, for this name, we can just select name from employees. If you want to access the individual elements, for example, here in the second field, if you want to access the element in the subordinate field, so the first element is our subordinate field is actually of array data type. We will be seeing that one by one later on. For that, we do the rest, and at last we will see how we access the actual elements of the complex data types. Here we see partitioning. Here we go with partitioning actually. For partitioning, just a minute, sir, just a minute. Next is actually partitioning. We will be partitioning using in the table customers according to the fields country and string. This customers data is will be scheduled as around sorry.
You will have the link in the document itself from which you can download.
4 or 5, I don't know. This is actual customer file, or not one. There's 5 records. It will be partitioning according to this.
Because of some network issues,
Let's do one thing for making our thing simple. Country is India, state is Tamil Nadu. I think I've already shown you that file tn-data.txt. Yes, this is the file. All these files, all these 5 records will be stored into that table within a separate partition inside the country, and inside country we will be having a separate partition named Tamil Nadu. Okay, I will show you after I execute this command. Hadoop FS-ls. Our external table will be stored in this file USTR slash hive slash warehouse. This is the actual warehouse directory for Hive, where these managed tables will be stored. Okay. We have two files, Hive and exe. This is the database in which we are working currently, and so let's go into the database. exive.db. So there's two tables, customers. This is the tables which we partitioned just now. To ensure the partition /customers inside customers. Yes. See, a separate. The partition field is again separate field country India. We want to view the subpartition again /OUNTRY equal to INDID. Yes. Partition for country India has been created. Inside that, a subpartition for state Tamil Nadu has been created. You can add any number of partitions again by just by stating the country name and followed by the state name. Each partition will be created inside this customers directory in the Hadoop file system. Fine. Let's go on with our Hive practice. Now we have ensured that the partition has been created successfully. Okay. Now let's just go on with creating external table. And again, will be this table is actually for practice. We'll create an external table.
Okay, so here we can stop here. What we can do, I will share you the content. You can do the practice. So it is already time for me to start the next session. So in today's session, we have discussed something about the dynamic partitioning, how to create external partition tables, and so on and so on. So we have left out with a discussion on how to, in coming classes, we will be discussing on Hive joins. What are the various types of joins? Apart from a simple join, we have map join, we have SMP join, when we need to make use of those joins. Okay, then after that we will have a discussion on how to handle JSON objects in Hive. So these are all the things that is left out. most probably in the coming Saturday we will cover all those joins and the associated how to handle JSON objects, and we will be dealing with 2 to 3 use cases by clubbing all the things that we have learned so far. Okay, so we have completed a discussion on this partitioning. We want to discuss on bucket. The plan for next Saturday and Sunday is, okay, here on Saturday we will be dealing with these basic joins, indexes, and some aggregate functions like group by, order by classes like thing. These are all some Hive building functions. Then followed with how to handle JSON data using Hive SERD. This is planned for Saturday, and on Sunday we will be discussing on Hive use cases. Okay, so by end of Sunday we can complete our session. We have Saturday and Sunday the same time, 8 a.m. IST to 10:30 a.m. IST. We can complete within Saturday and Sunday. Okay, I will share you what it is currently shown to you by Abid. Since my machine is got corrupted with Hadoop, morning only I recognized I couldn't able to start. I want to format, I want to recreate, format it took around 1.5 hours. So to overcome those sort of things, we have worked with he is my student, Mr. Abid, who is my student currently working with Infosys as a big data architect. We get the assistance of his what he did. Okay, so Ashok sir, thank you. I will share you the yesterday's and today's recording along with the document that is shared to you to do the remaining practice.